Hello, everybody, and welcome back. Today we are talking about conic sections and specifically about parabolas. I will be talking about the relationship between the focus point and the directrix and how to get the parabola equation from this relationship. In the FE handbook, you are giving a graph on parabolas and then an equation underneath. So I go from this relationship of focus point and directrix and come up with that equation you're giving underneath so that you understand what exactly it comes from. And that being said, let's just jump straight into our examples for today. This is the information you are given in the FE handbook about parabola, and you're giving this graph here, and you're giving the formula down here, y minus k squared equals to 2p multiplied by x minus h. And center at hk is the standard form of the equation when h equals k equals 0. Focus is p over 2, 0. Directrix is x equals to minus p over 2. So I'm just trying to talk about the relation between the focus and the directrix, which is not shown on a graph. So you would not really, if you're not familiar with the relation between directrix and focus, you would know where this comes from. So I'm trying to show the directrix and show the relation between the directrix and focus and come up with this formula so you know where it comes from. So the relation between the focus, so this is F over here, and directrix, I'll show the directrix on the other side. This is the x-axis. This is the best I could do. So directrix is at the equal distance from the vertex, which this is the vertex of the formula of the parabola. So directrix is at the same distance from vertex as focus is from vertex. So I will draw the directrix right here. Let me call it directrix. And when I look at the focus, I'm seeing focus coordinates is h plus p over 2k. Vertex, this is vertex, parabola's vertex, which is hk. And focus is h plus p over 2, which means the distance over here is p over 2. And we know that the directrix is at the same distance from the vertex as focus is from the vertex. So that means that this distance is also p over 2. And now knowing this, we can write what the directrix is. So the directrix intersects the x-axis. So that means we're going to have x equals to h minus p over 2. Okay. The relation between focus and directrix tells us that if you take any point on the parabola, hope you can see this. Let's take, I don't know, this point over here. So if I take this point and I go from focus to this point on the parabola, this distance here is equal to the distance from that point on the parabola to the directrix. And of course, here on the directrix we have a 90-degree angle. And this is true with any point on the parabola. I'm going to use another color. So if I get to take, let's say, this point over here on the parabola, and I go from focus to this point, then this distance in red equals to this distance over here, which falls perpendicular on the directrix. So this is the relation between the focus and the directrix. And this is where they came up with this equation, and I will get to it because I'm going to calculate it. So again, any point on the parabola and the distance from the focus to any point on the parabola is equal to the distance from that point to the directrix. And this is actually how a parabola is defined. So now I will just take this, let's go ahead with this point. I will call it X, Y. And this is the focus point. We have the coordinates over here. And this is the directrix. We have the directrix coordinates over here. And let's calculate, or let's set these two distances equal. So this distance that I'm going to show here in green, now this is easy to do because we know what is the distance between 2 points when we have the coordinates. And this point's coordinate is h minus p over 2y, because it has the same y. So the distance is going to be actually just the difference in the x coordinates. X minus, and the coordinate of the directrix is h minus p over 2. So here, in order to avoid to get a negative number, I will just square this and take square root of that. Hope this makes sense. It's just in order to avoid the getting a negative number, because the distance, it's always positive. So we're just going to square it and then take square root of that. And this in green is this distance over here from this arbitrary point on the parabola to the directrix. And now we have to make this equal. This distance is equal to this distance that goes from this point to the focus. This distance I have here in D. So what is that distance equal to? Now this is hopefully, this is just a Pythagorean theorem where we have a right triangle. I'm going to show it here in red. And this is the change in y. This little piece is change in x. And d is going to be square root of dx delta x squared plus delta y squared. So let's write that down. We're going to have d is equal to delta x is x minus h plus p over 2 squared plus delta y is y minus k squared. So now let's get rid of the radicals and square both sides, as well as get rid of this parenthesis inside this square parenthesis. Here I'm missing this square parenthesis. So let's go ahead and do that. I will square both sides. So we're going to get x minus h. And we have minus and minus, that's plus p over 2 squared. And this is going to be equal to the other side. We get rid of the radical as well. So here we have x minus h minus p over 2 squared plus y minus k squared. And here, notice we have a little bit of a messy parenthesis here, all squared. So in order to simplify, I will just take this member as A, and this member is going to be as B. And this is the formula A plus B squared, which is A squared plus B squared plus 2AB. And the same thing is going to be on the other side. We're going to have here this as A, and this is going to be B. But instead of A plus B, we have A minus B. And the formula is somewhat similar, where we have A squared plus B squared minus 2AB. And just so you know, I believe these formulas are in the FE handbook. You have them there. So let's go ahead and do that. We're going to continue with x minus b squared plus p squared over 4 plus 2p over 2 multiplied by x minus h. So this is all of this parenthesis over here equals. Now let's work on this second parenthesis. We have x minus h squared plus p squared over 4, and now it's minus 2p over 2 multiplied by x minus h. And moving forward, we have also this term here. I'll add it plus y minus k all squared. Okay, so now we can, if you look carefully on both sides, let's see, there might be some terms that will cancel each other out. And I see this one and this one going to cancel each other. They're going to cancel each other out. And we have x minus h, this is h here, squared, and x minus h squared. It's going to also cancel each other. So we're left with this term here, which I'm going to cancel the 2's. So we have p x minus h, and we have another p x minus h on the other side. So if I take it on the other side of the equal sign, this is going to become a positive. So I have plus p x minus h equals to y minus k squared. So let's rewrite this. I'm just going to do this member first. So I'll have y minus k squared equals 2. And if I would add these two members, I'll get 2p multiplied x minus h. And if you look carefully, this is exactly what you have here, and you're given in the FE handbook. And it's very nice to know where exactly this comes from, because you're not shown the directrix in the FE handbook. And so this graph is not quite complete for you to understand it. But if you know the relation between the focus and the directrix, you can understand and know that this relation here that you are giving in the FE handbook comes from the relation between the focus and the directrix, which says that the distance here equals to the distance from the parabola to the directrix. And that's all we did over here. I hope this is clear. And now let's work on an example, or on a few examples. I have 2 examples for you today. Write the equation for a parabola with a focus at 6 minus 4 and a directrix at y equals to minus 7. So first, let's just draw the directrix is at minus 7. Try and draw a straight line as much as I can. So this is the directrix, which is given in the problem. And directrix is y equals to minus 7. And the focus point of the parabola is at 6 minus 4. So we go here, 6, 2, 3, 4. This is the focus point of the parabola, 6 minus 4. And now we know the vertex of the parabola is in the middle distance between focus point and the directrix. So the vertex of the parabola is going to sit here, and our parabola is going to look something like that. There you go. So now what we know about this, the relation between focus and directrix, is that if we take any point on the parabola, this means that the distance here, and let's call this point x, y, and this distance here is equal to this distance over here, and this falls perpendicular on the directrix. So now let's write the same relation and find the equation of this parabola. So first off, we're going to start by again, these 2 points, they have the same x, right? The same x, which is at 2.3 approximately, and the y's are different. So this distance is going to be the difference in y. So we're going to have y minus minus 7, and y minus minus 7 is x, so I'm writing x, is y plus 7. And I'm going to square this and take the square root of that to avoid getting a negative number. And now this distance over here is just the Pythagoras theorem. So we have square root of x minus 6 squared plus y plus 4, because is y minus minus 4, so it's y plus 4 squared. And now we're going to get rid of the radicals by squaring both sides, and we are going to be left with y plus 7 squared equals to x minus 6 squared plus y plus 4 squared. And now let's open the parentheses. We're going to have y squared plus 49, which is 7 squared, plus 14y equals to, this member, I will write it the same. We're now going to open the parentheses. X minus 6 squared, and let's open this parenthesis. We're going to have y squared plus 16 plus 8y. And looking at both sides, this member and this member are going to cancel each other out. And we're going to be left with, we have 14y here, we have 8y here. When we take this y on the other side of the equal sign, it becomes negative. So we have 14 minus 6. It's going to give me 6y equals to x minus 6 squared. And I have 16 minus 49. Taking this 49 on the other side of the equal sign, it changes the sign. So it becomes minus. So minus 49 plus 16, I get minus 33. And now let's just solve for y. And this is going to be equal. I'll move here on the other side. Y is equal to x minus 6 squared over 6 minus 33 over 6. And of course, if we divide both sides by 3, we're going to get 11 and here 2. So we can rewrite this as y equal to x minus 6 squared over 6 minus 11 over 2. And this is the equation of this parabola with the focus at 6 minus 4 and directrix at minus 7. And looking at the answers here, 1 over 6, x minus 6 squared, A seems the right answer. Everything else, it doesn't match. This is plus, so it's not correct one. Okay, so A is our correct answer. And now problem number 2, we have write the equation for a parabola with a focus at minus 2, 5 and directrix at x equals to 3. So again, let's just add the directrix here. X equals to 3. 3 is over here, and I'm going to draw this line all the way down. This is x equals to 3. And the point minus 2, 5 is going to be minus 2, 2, 3, 4, 5 right here. And what do we know? The relation between focus and directrix is that the vertex of that parabola is the midpoint between focus and directrix. So this is going to be the vertex of my parabola. And the parabola is going to look something like this. And this distance, right, equals to this distance. This is what we know. And it's 2.5, 2.5 on both sides. So now we know that the distance between focus and any point on the parabola has to be equal to the distance from that point to the directrix. Let's take an arbitrary point x, y, and we're going to write the same what we did before. We're going to write the distance between the focus point, which is -2, 5, and equal to the distance from the point on that parabola to the directrix. Let's do that. So we're going to have first x minus 3. And again, to avoid having or getting a negative number, I will square this and take the square root of that. And then the distance between this arbitrary point on the parabola to the focus point is going to be x minus -2, which is going to be +2 squared, plus y minus 5 squared. And we're going to do the same thing moving forward, just squaring both sides to get rid of the radicals. F squared equals to x plus 2 squared plus y minus 5 squared. And then we are just going to open the parentheses like we just did before. X squared plus 9 minus 6x equals to x squared plus 4 plus 4x plus y minus 5 squared. And looking at both sides, these two are going to cancel each other out. And we have minus x and plus 4x on the other side. If we take this 4x on the other side of the equal sign, it becomes negative. So we're going to have minus 10x equals 2. I will write y minus 5 squared. And we're left with 4. If 9 goes to the other side, becomes negative. So we're going to have minus 9 plus 4 minus 5. And moving forward here, I'm going to go here, move here. So we're going to get x equals to y minus 5 squared over minus 10 plus, right? Becomes plus because we're going to have, or I can, let me just write minus so you don't get confused. I'll do minus 5 divided by minus 10. Okay, so again, let me rewrite this as x equals to minus y minus 5 squared divided by 10. And then this minus and this minus becomes plus. And if we divide both sides by, or both numbers by 5, we're going to get 1 over 2. So it's going to be plus 1 over 2. And here we go again, we found the equation of this parabola based on the relation between the focus point and the directrix. I hope this is clear. If it's not, please don't hesitate to leave your question or a comment in the comment section below. That is it for today, my friends. I hope you found this video helpful. And if you did, please don't forget to subscribe and give it a like because this helps people like you find my videos. If you have any questions about today's video, please leave it in the comment section below. As always, I want to remind you, or all of you who are interested in doing a credential evaluation, I have a guide that takes you step by step on how to do that. Click the link below and I will send it to your email inbox. Another guide that I have recently worked on is called Integral Calculus, and it has examples with solutions on standard integrals, integration by parts, integration by substitution, and integration by separable variables. So if you're interested in that, click the link below and you are going to receive it in your email inbox. Don't forget to keep up the good work on practicing the FE problems, and I will see you next week.